Hey everyone, as always, welcome to the channel. I'm back working on the 402 Big Block Chevy rebuild for my 70 Chevelle, and I'm at the point now where it's time to set up the new hydraulic roller camshaft that I've installed. So what I'm going to be doing is degreeing and checking the cam against the manufacturer's specifications, and then I also need to check the cam in play and adjust that as necessary. Now, I'm going to be 100% honest here. I don't know if it matters if one is done before the other, but what I'm going to do is I'm going to degree the cam first, and again, I'm just going to check it against the manufacturer's specifications and make sure everything's squared away. My plan is to install it straight up. It already has 4 degrees advance ground into it, but I'm going to go ahead and just check it to make sure that everything's in good shape. There are a number of factors that can throw those off just a little bit. So again, I'm just going to degree it real quick and make sure that we're all squared away. Once I'm done degreeing the cam, then I'm going to circle back and I'm going to check the cam in play and make sure that that's within spec as well. And if I need to adjust it, I will, and I'll just use my cam button to make sure that we've got the correct cam in play, and we'll go from there. Okay guys, so I've got the camshaft and the timing set all installed here. So I thought I would just comment a little bit on the components that I'm using. So as I might have mentioned earlier, this is a Straub Technologies hydraulic roller camshaft. It's got 280 degrees of duration. That's on the intake side, and then on the exhaust side, the duration is 294. It's a pretty wide overlap in terms of the 280 versus the 294. But in talking with the Straub guys, it sounded like this was the perfect fit for my application, where I'm going to be using cast iron heads. So that's the camshaft that I'll be using. I'm also using a 9-way timing set. It's a Rollmaster timing set. I'll put a link in the description. Set. It has the Torrington bearing on the back side of it. So that's what I'm going with here. And then you can see I've got the cam button installed as well. Just a steel cam button with needle bearing set. You can also get a nylon button as well. I got that from Straub Technologies as well, part number 101-945. And then of course I'm using a cam locking plate here. And you can just find those at pretty much any parts house that sells these types of components. So just the cam locking plate there. And then the lifters, I actually, rather than use the lifters that Straub typically recommends or sells, I think they like or prefer the Morel lifters. I actually have a set of Howard's hydraulic roller lifters here. So these are what I'm going to be using for this build. Part number for the Howard's lifters here is 91161, and again, I'll put a link in the description. So those are the components that are going into this build. So now what we'll do is we'll just get busy on degreeing the cam, and we'll also be setting the end play. All right, so like I said, I'm going to start by degreeing the camshaft. So you can see here that I've got my degree wheel installed on the crank, and I've also got my pointer in place. This is just a pointer that I made with some wire, so just a little homemade jobby here, but that should allow us to take some accurate readings on the degree wheel. So once you have your degree wheel and your pointer in place, the next step would be to find top dead center on the number 1 cylinder. And that can be done using a number of measuring devices. What I'm using here is just a dial indicator on a magnetic stand. You can also use a piston bridge that bridges the piston, a magnetic bridge that comes across the piston bore here and has dial indicators on it. That's a great way to do it. You can also use a piston stop that basically bridges the bore itself fairly flush, and then you're able to determine top dead center with that method. If you have the heads on it, you can actually even put a piston stop in the spark plug hole. So any of those ways are good ways to do it. I think the most important thing is that you're just careful, you take your time, and you just want to make sure that you're taking accurate measurements. Okay, so to find top dead center here, all I'm going to do is I'm going to rotate the crankshaft clockwise, and what that's going to do is bring the piston to the top of the cylinder. As the piston is climbing, the needle on the indicator gauge is also going to climb. And what I want to do then is just make sure that I take note of the highest point of travel on the dial indicator. And so once I have that determined, I can set the dial indicator back to 0. And then what I'll do is I'll just come back and rotate the engine over 2 or 3 times, making sure that each time the piston comes to the top of the cylinder, the needle goes all the way to this 0 set point. If it's different than that, then I want to make sure that I make those adjustments. But really the goal here is to find the height of travel on the piston by using the indicator gauge. On ahead and found top dead center, and I just did that following the same procedure that I had just described, where I rotated the crank clockwise, bringing the piston to the top of the bore. And as that piston starts to climb, the needle is going to start to climb. And when the piston reaches top dead center, the needle's going to stop and then fall back. And the point at which it stops is top dead center. And so that's what I was watching for. So what I've done is I've actually zeroed out the dial indicator now. And so top dead center should be right where the 0 is. It's basically where my finger is. So let's just check it one more time. And again, what we're looking for is that the needle makes it all the way to 0, but doesn't go past 0 before falling back. And there you can see it made it to 0 and started to fall back. So the 0 on the dial indicator is indeed top dead center. Now the next thing that we want to do is we want to stop on top dead center. So I'm just going to bring it back and get it right on top dead center. And what we'll do now is we're going to go down to the degree wheel and make sure that the pointer is pointing at top dead center, and then we should be good to go. What we can do now is just come down to the degree wheel and see where the pointer is lined up. And in this case, it's already lined up on 0. Now, in all fairness, I've already done the adjustment here. But if for some reason, once you get the piston to top dead center and you come down and look at your degree wheel and the pointer isn't on 0, what you can do is just simply move the pointer to 0 so that everything lines up, and that now is your top dead center reference point. So now what we're going to do is we're just going to make one last confirmation that we are truly at top dead center, and we'll do that by rotating the crank 50 thousandths past top dead center and 50 thousandths before top dead center. And what we'll do is we'll take measurements on both sides. Those should be equal measurements. If they are, we're at top dead center. If they're not, we'll have to do a little bit of adjustment. We've got the piston at top dead center now. We've got the pointer on the 0 on the degree wheel. And now all we need to do is take 2 more measurements to make sure that we're truly at top dead center. So what I'm going to do is I'm going to rotate the crank counterclockwise until the dial indicator reads 50 thousandths from top dead center. And we're going to check to see where the pointer is on the degree wheel. When the piston's 50 thousandths before top dead center, it looks like we're at about 11.5 degrees on the degree wheel. So we'll write that number down, and now what we'll do is we'll turn the crank the other direction and we'll get the piston 50 thousandths past top dead center. Now I have the piston 50 thousandths after top dead center, and it looks like we're at 11.5 on the degree wheel. So both readings are 11.5 degrees, which is great news. It means we are at top dead center, and we can move on to the next step. Okay, so let me show you something here just real quick. If for some reason when you're taking those readings 50 thousandths before and after top dead center, that you don't have the same number on both sides of 0. So what you can do in that case is you can add both of those readings together, divide by 2, and then what you want to do is bring the degree wheel around until the pointer is on that particular number. So in this case, I'll just use some arbitrary numbers, but let's say that my first reading was 30 and then my second reading was 130. So what I am going to do here is add both of those together. That's 160. Divide by 2 is 80. So now what I want to do is I want to get the pointer here on 80, or bring the wheel to 80 degrees. So I'm just going to kind of keep going in the normal rotation of the engine. I'm going to bring the degree wheel to 8 so that the pointer is at 80, and go from there. Okay, so now I'm right at 80 degrees on the wheel. And so again, that is the difference between the two readings that I had taken. This should be true top dead center. What we want to do now is loosen the bolt and spin the degree wheel so that the 0 is lined up. Now keep in mind, you don't want to move the crank at this point. You want to just move the degree wheel. We'll just rotate the degree wheel until we get the pointer lined up with 0. And now we should be at top dead center. So we'll tighten the bolt up. And what we'll do now is we'll just double check. We're going to just kind of run through the process again. We'll take a measurement 50 thousandths before and after top dead center. And we should now be the same distance, 12 degrees likely, on both sides of 0. And top dead center is confirmed. Next up is determining the intake center line of the camshaft. So I've got my dial indicator on the magnetic stand set up here. I've got a push rod that I'm using, and then I've got the roller lifters down in the bore, and so we should be good to go. Now, I know that there are some guys that worry about the plunger compressing during this step. I'm not going to worry about that here. There's really no pressure on the lifter itself, so I'm not going to worry about it. I think I'll still be able to get an accurate reading here. One of the things that's probably the most important, though, is making sure that you're taking straight line readings. So you want to make sure that you've got your push rod nice and straight here. You've got it at the correct angle, or as close to the angle that it would be in the engine itself. And then I've got it kind of a nice lineup with the dial indicator here. That's probably going to be one of the most important things. Again, just making sure that you're taking those straight line readings. Okay, so now that I've got everything set up here, I'm going to start taking some readings using the #1 intake lifter here. And the first thing that I want to do is just find max lift of the camshaft itself. Once I find max lift, we're going to set the dial indicator to 0, and then we're going to start taking some readings. To find max lift on the intake lobe, I'm just going to rotate the crank clockwise, and as that lifter comes up, I'm just going to watch the dial indicator for a maximum reading. And once I know what that maximum reading is, I'm going to reset the dial indicator to 0, and then from there we'll take our next measurements. Okay, so I found max lift on the intake lobe. I've got the dial indicator set to 0, and what I'm going to do now is rotate the engine counterclockwise until the lifter drops 50 thousandths of an inch, and then we're going to take a reading here on the degree wheel. So it looks like we're at about 60.5 degrees on the wheel here, so we're going to write that number down. And now what we'll do is we'll turn the engine clockwise. We'll bring the lifter back up to maximum height, and then we will just keep going until the lifter drops another 50 thousandths, and we will take that reading. All right, so we're back at max height now, and now we're creeping down to 50 thousandths past max height. And as we can see here, it looks like we're at about 140 degrees, so we're going to write that down. Now that we have our degree wheel readings, when the piston's 50 thousandths before and after top dead center, we can just take both of those readings and add them together, divide by 2, and that will give us the intake center line of the cam as it's currently installed. So our first reading was 60.5, second reading 140. 200.5 divided by 2 is 100.25. So we'll just call it 100 in this case. And so when we compare that to what the cam card says, the intake center line should actually be 105 when it's installed straight up. So it looks like we're going to have to do some adjustments here. We're going to have to retard the cam. So that won't be a problem. We'll go ahead and give that a shot and see if we can get a little bit closer to this intake center line. Before I do that, one of the things that I'll do is I'll just go ahead and check the intake valve opening events. So I'm just going to run back over to the engine and go ahead and take those measurements, and then we'll come back and I'll show you what they turn out to be. My guess is that they're going to be off by 4 to 5 degrees as well, and then we can come up with a game plan from there. As I was mentioning earlier, the camshaft manufacturer, Straub Technologies in this case, actually prefer that their camshafts be degreed using the IVO or the intake valve opening method. So it's easy enough to do. I've still got everything set up here from when I was checking the intake center line. So we're just going to kind of go from here. So the first thing that I want to do is I'm going to bring the intake lifter or valve down to the base circle. Once I'm on the base circle of the camshaft, I'm just going to set the dial indicator to 0. And then what I'll do is continue to rotate the engine clockwise, the same natural rotation of the engine itself, until I'm at 50 thousandths lift. I'll take a reading. Then I will continue to rotate the engine clockwise until I reach max lift, and then what I want to do is bring it back down to 50 thousandths before the base circle. So we're going to go ahead and take those two readings. We're going to get the intake valve opening event and the intake valve closing event, and it'll be interesting to compare those results to the cam card, because if you remember, my intake center line came out to be a little bit different than what was on the cam cards. So just a little bit of rotation of the crank here, and we will get this lifter on the base circle, and we will reset the dial indicator to 0. And then we'll be able to take some of our measurements here. So as soon as this stops moving, we'll know that we're on the base circle. So there we go, we're on the base circle now. So we're just going to adjust the dial indicator to 0, just like so. And now what we want to do is we are going to continue rotating the engine clockwise, and we're going to take it to 50 thousandths lift. Okay, so we're at 50 thousandths lift on the intake side of things, so we'll just go down and take a reading off of the degree wheel. The angle might be a little tough to see here, but it looks like we're at about 8.5 degrees. So that's the number that I'm going to write down for the intake valve opening event. And now what we'll do is we'll just continue to turn the crankshaft over. What we want to do now is take the lifter all the way to 50 thousandths before the base circle and take a reading there. That'll give us our intake valve closing event, and then we'll have both of our measurements. One of the other things that can be done at this point, since the dial indicator has been zeroed out while the lifter's on the base circle, you can actually double check the max lift on the cam itself. So I'll do that real quick too, just to see how that matches up against the cam card. I'm already at 50 thousandths lift. Remember, that's the reading that I just took here on the intake valve opening event. So I'm already at 50 thousandths, and so I'm just going to count the revolutions here. I'm going to see where the needle maxes out, and that'll give me the lift value again on the intake side. This cam card is 340 on the lift. So let's just check it and see how close we are. So again, we're at 50 already. We're at 100, 200, 300, and now we should get pretty close to 40. I know that dial's wobbling a little bit, but here we go. We're at 3. Looks like we're getting about 339. So we're not quite at 340, but 339 is as close as I think I can expect it to be. So that's how I do the max lift. I can do the exact same thing on the exhaust lobe if I want, but I think I'm going to be pretty happy just doing it here on the intake lobe. Okay, so I'm at max lift here, like I said, 339, 340 lift here. So I'm just going to use that number to help me do the math backwards, because what I want to do now is find the intake valve closing event. And again, I want to take it to 50 thousandths before it hits the base circle. So really what we're going to do here is just go backwards until we get to 50. So to make the math easy, I know I'm at 340 here. So if I come here, now I know that I've got 300 before I get to the base circle. So I'm just going to go another 250. That'll put me at 50 thousandths before the base circle, and we'll take that reading. So there's 100, there's 200, and now we're going to stop right at 50 if I can get it there. One more little squooch. There we go. So now we're at 50 thousandths before we hit the base circle again. So let's go down to the degree wheel. We'll check that reading, and then we're going to compare it to the cam card. Alrighty, Alrighty, so now that I'm 50 thousandths before base circle, I'm down here looking at the degree wheel, and it looks like I'm at about 32 degrees. Again, I don't know if this is going to show up on the camera or not, at 32 degrees. Now, I know that looks like it's 148, but remember, these degree wheels are broken up into 180 degree sections. So we can actually start counting backwards from the 180 spot here. So we're really at 32 degrees. For this reading. So now we can take the 8.5 that we have on the intake valve opening event. We can take the 32 degrees that we have on the intake closing event. Let's compare those to the cam card and see where we are. Because like I said earlier, the cam manufacturer, they want this camshaft to be degreed to the intake valve opening event. Okay, so I'm back over at the bench now just to take a look at the intake valve opening and the intake valve closing events. And so it looks like the IVO was 8.5, the IVC was 32. If we compare that to the cam card, very similar to the intake center line, we are off about 3 to 4 degrees. So the cam card says that the IVO on this cam should be 5.5. We got 8.5, and then the IVC, or the intake valve closing event, should be 35.5, and we measured 32. So like I said, very similar to the intake center line, we are off, 3 to 5 degrees. So what we're going to do now, because I just want to install this cam straight up, is I'm going to go back over. We're going to take the timing set off, and we're going to retard the crank sprocket 4 degrees and put it all back together, and then we'll run through the intake center line and the IVO IVC measurements again and see where we fall. So we're going to go back over there and get that started here coming up. I initially installed the timing set straight up, or dot to dot, and as you saw from the green of the cam, the measurements that I came up with, I'm about 3 to 4 degrees off. I'm actually advanced. So what I'm going to do now is just retard the cam about 4 degrees. Hopefully that will bring me back into the into plus or minus 1 or 2 degrees of what the cam manufacturer says. Again, I'm targeting 105 on the center line, and we're targeting, I think, 5.5 degrees on the IVO. So I've got a nice 9-way timing set here, so I'm just going to take the crank sprocket and I'm going to turn it to the -4 position. You may have a sprocket that has plus and minuses, or it might be A's and R's, advanced and retarded. So again, I'm just going to turn this, just going to pivot it around and clock it here so that I'm at the -4 location, and get the cam, or get the crank sprocket driven back on. We'll put the timing set back in, and then what we'll need to do is we'll need to start all over again and find top dead center, and then we will check the intake center line and the intake valve opening and closing events. I've clocked the crank sprocket here to the -4, or the 4R location right here for the keyway, and I have reinstalled the timing set. And now what I have is I've got the dot on the cam gear, or the cam sprocket, lined up with the -4 or the 4R on the crank sprocket here. So we should be 4 degrees retarded now. So what we're going to do is we're going to go through, we're going to recheck and refine top dead center, then we're going to do the intake center line, and then we'll also do the IVO, or the intake valve opening event, the timing event. So those are what's up next. The other thing too is I've got the cam button in place now, because the next step after we get the cam degreed will be to check the end play, and I'm also using a cam locking plate. As you can see here, this is the older gen block, so it doesn't have the provisions for the retainer that some of the newer blocks have. The other thing is I never use Loctite on the cam bolts, or fold these tabs over on the cam locking plate until all of my cam setup is done. That way I don't have any issues if I need to remove the gear. So, definitely be thinking about that. Don't get too excited and do all that stuff straight away. As you know, I had to remove this timing set because the camshaft didn't agree according to the specifications on the cam card. So always good not to use Loctite on your bolts or flip those ears over on the locking plate until after you have everything where it needs to be. All right, kids, so if you've been following along at home, you know that the first time around agreeing the cam, the numbers didn't quite match the cam card, so I had to remove the timing set and retard the cam 4 degrees. I've got everything back together now, so I'm gonna have to start all over again with the cam degreeing process. I'm gonna speed up the video here while I find top dead center, the intake center line, and the intake valve timing events, but I'm gonna follow the same procedures that I walked through earlier in the video. Once I have all of those numbers, I'll come back and I'll show you how everything turned out. Okay, so after retarding the cam, I've taken some new measurements off the degree wheel. So let's see how things turned out here. So the intake center line, these are going to be the two readings, one 50 thousandths before top dead center, one 50 thousandths after top dead center. So these readings turned out to be 65.5 and 146.5. So if we add those two together, we get 212. And then if we divide by 2, we get 106. So that is the intake center line now that the cam has been retarded. That is the intake center line that I have. If I compare that to the cam card, it should be 105. So we're really close here. We're within that 2 degrees that the cam manufacturer recommends. So we should be in good shape here. But now let's see how the intake valve opening and closing events turned out. So if we look at those, the intake valve opening was 4.5. The intake valve close was 37. If we compare that to the cam card and what they should be, we see 5.5 here for the intake valve opening, and for the intake valve closing event, 35.5. So if we compare the reading that we got off of the wheel and the cam manufacturer's specification, we're really close. So again, we're within that 2 degrees, and the same thing for the IVC. So I'm pretty happy with the way things are now. We're going to leave the cam where it is. It's matching the cam card. So we should be basically done degreeing the cam at this point. Next thing that we're going to do is I'm going to move on to checking and setting the cam in place. So if you get a chance, be sure to come back